In this video, I'm going to show you how the k-mean algorithm is written in Matlab. Before then, let's quickly go through the k-mean algorithm. With the k-mean algorithm, you have your inputs to be the number of clusters in the training set. So the algorithm is as follows. You randomly select the number of clusters. Then for each of the data set, you assign a cluster index to it. And you then compute the average points assigned to each cluster. The process is repeated until the cluster point does not change. That's where you know you've reached convergent. So in this code, I start with a maximum iteration of 30 with 3 clusters, and my intolerance level is 0.00001. I initialize a random data, initialize cluster index of zeros, centroids of zeros. For this particular part, I generate a random index, then pass that index to the data point generated to select the cluster. Then I assign it to the centroids. So I start my code from this part after generating the centroid. So I compute my Euclidean distance, which will be used to assign a centroid. And it should be noted that for Euclidean distance, you don't need to go through this process. Matlab has a built-in function for that, which is PDST2. We have PDST and PDST2. You can check for more details. Then you classify your data according to the index for each cluster. So you use the find to get the index. And if the index happens to be more than 2 vectors or 2 data points, you select the minimum and you assign that to a particular data point. So after computing all the data points, then you compute the average for each of the cluster. And this portion of the code checks whether we've reached convergence. If we've reached convergence, the code will exit the while loop, and then this part classifies the index, the data point into each index. So as you can see, for this part of the classification is as I shown you on the PowerPoint. You have it here. For 1:m, you assign each of the data set to a particular cluster. Compute the average point assigned to a cluster. So that's what you see here. You have your data point here, then you have the mean of each cluster to here. So let's run this code and see what we get. So we have 3 clusters and our data point, our algorithm has been able to classify it. And you should note that initialization of the centroid is very important, because if the centroid is at different place, you will get different results. So let's run the code again. See, so when you can also change the data point to maybe 5. Let's see, you get 5 centroid, 15. So you get the 15 centroids. That's how this k-mean algorithm works. Take your time and go through it and practice to get more. Okay, let me run the code again and see. Here you have your 3 centroid initialized randomly. Then after the classification, you have the centroid reposition itself. Then we do the classification here again. So randomly initialize, run the code to reposition the centroid, then classify the data points according to the position of the centroid. That's how it works. So let's run again. These are 3 cluster points. So we have the position of the centroid initialized. It has repositioned itself after the classification. Then we finally classify each of the data points to each cluster. So that's how it works. You can try with different clusters. We have six. We have six here. You can try with let's say 15. We have our 15 data points in here. First one here and the final after the code after the centroid has repositioned itself, and we have this. So hope you find this helpful, and thank you for watching.